So in this tutorial we're moving over to doing questions in C. So firstly we have looking at some different data types that we commonly find in C. So our first one there, we've got a character, 8 bits, and our values are minus 128 to plus 127 maximum value. Let's look at each of the different data types that we have. A signed character is actually exactly the same as a character, so if we don't write signed there, it defaults to being a character, so it's the same as the previous one, minus 128 to plus 127. An unsigned character, remember the top bit is the signed bit. Normally in a signed one, in an unsigned we just use it to store data, so the smallest value we can have is 0, we can't have negative numbers. The largest value we can have is 255. Next we have our integer. Now an integer and a signed integer are going to be the same thing. So minus 32,768 to plus 32,767. And it's the same for both of them. Okay, unsigned, once again, the smallest value we can have is 0, largest value we can have 65,535. And for an unsigned long integer, here we're using 32 bits rather than 16 bits here. Once again, smallest value you can have is still 0, largest value you can have now is a lot larger. So we have 2 to the power of 32 minus 1. Okay, here we need to choose the most appropriate variable. So we're not wasting a whole lot of space as well. So this first one, we notice we've only got positive numbers and they fit within the range of 0 to 255. So it makes sense that we'd use an unsigned character. So we'll give it the value A. Unsigned char A. Next, now we have positive and negative numbers, and we're out of the range of being able to use characters, so now we need to use integers. So we can say signed int, or just int, which is actually a signed int, A variable will store numbers from 0 to 56,000. Well, this can be unsigned int A, and numbers from 0 to 70,000. Well, now we're getting into longer numbers, so we use a long unsigned int A. Okay, in this question what we want to do is add up all the values in our array. So we've got 5 different values there. We want to have a bit of a loop that goes through and adds them all up. Of course we need to define this variable called result and also initialize it, otherwise who knows what was in result to start off with. So let's do that first. We'll define it as a signed int, because we notice there's positive and negative numbers there. So signed int result equals 0, so we're initializing it. We'll have a variable that we're going to use to increment through this array as well. So int I, and easiest way to do this is probably with a for loop. So we say for I equals 0, so the first element in the array. While I is less than 5, we keep on going and we say I++, which allows us to increment. Then we can say result is equal to result plus a, and we're looking for the ith bit, or the ith element of the array A. Another way we could do it, somewhat shorthand, is to say, instead of doing this line here with result, we say result plus equals, and essentially that's taking out this element here, and we're saying we want to add something to itself, a I. Okay, bit easier to read, does exactly the same thing. Finally, in each of these we want to work out what the value of result is at the end. To work that out, it's easier stepping through each line of code. So along the side here I'm just going to write what x equals in each case. So we're assigning 12 to it, so x equals 12, we add 2 to it, x equals 14. We shift it up twice, that effectively doubles it twice, so it's equal to 56. So result is equal to 56. Next, we've got an unsigned int y, so these can only be positive numbers, not negative numbers. So we set to 0 at the start, so it's obviously 0. We subtract 1 from it. Now we went from having 0x 0 0 0 0, we subtract 1 from it, and what we get is f f f f, which is an unsigned integer, so it needs to be a positive number, is 65,535. Now what we're doing is flipping the bottom bit. So the bottom bit we're XORing with 1. That effectively changes this to a 0x f f f e. The bottom bit's now going to be a 0 because it's been flipped. So 65,534. Okay, now we've got a signed number again. So it's equal to 23. We've written that. Now we want to do an OR with that, and we're ORing it with 4D. So if we do an OR with 4D, that will give us a result of 95, which in hex is 0x5f. Then we're dividing it by 2. Now when we do integer divisions, we're doing essentially a shift right, and so the result will give us 47. And then we're ANDing it with this number here, which is essentially going to AND it with this tilde here, inverts this number. So we're essentially going to be ANDing it with something that looks a bit like this, a whole bunch of 1s, and right at the end a 0 in binary. What that's going to do is, if we AND something with 1, well, it will stay the same. If we AND something with 0, it'll clear that bit. So it's actually going to clear the bottom bit. So the bottom bit's cleared, it'll give us a value of 46. Next, here we're using a hash define. So we're defining A as 32. Where we've got a character's 3, so we've got 3 there. We're ORing that value 3 with the value 32, which will mean that P will now equal 35. What we're then doing is doing 2 commands at once. So we're adding something and we're subtracting. So the way we do this part is done first, this part here is done second. It's probably easiest to see how this works we put it into binary. So 3 in binary is a whole bunch of zeros and 1 1. 32 in binary is 0 0 1 0 0 0 0 0. Now if we OR these together, we're ORing bit for bit, bit for bit, bit for bit. So 1 or 0 is 1, 1 or 0 is 1, 0 or 0, 0 0 0, 1 or 0 is 1, and 0 0. Now if we convert that back, it will give us our 35, as we have here. Okay, for this next one, we need to do it in 2 stages. So first stage is working out what we're going to be adding to P. So we take A minus 2 is 30, and then we add that to P. So P will now equal 35 plus 30 equals 65. So just remember a quick refresh on all these operators. We have our OR operator. Now we're normally using that to set things to 1. We have our AND operator. We're normally using that to set things to 0. And we have our XOR operator, which is the caret. And we're normally using that to invert bits.